Hi, I'm Charani Hasara. Today I'm going to describe about binary trees. Before discussing about binary trees, what is a tree actually? It's a data structure. It's a kind of data structure, but unlike arrays list, it's a hierarchical data structure. So normally a tree is like this, but the data structural trees, we consider it in up this side, I mean in upside down. So the topmost element of this tree is known as the root of that tree. All the elements below the root are known as children. So these are children of this tree. The element directly above any of the element. I mean, let's get this as an example. So for this element, this is the directly above element. So this element is the parent of this child element. This is the hierarchical structure of a tree. So there are some differences between a binary tree and a normal tree actually. So in a binary tree, it only can contain maximum 2 children. That means it can contain 1 or 2 or else no children. And if this is a binary tree, if I consider this node, it contains 2 children. So the child in the left side is known as the left child and the child in the right side is known as the right child. So in binary trees, every node contains data as well a pointer to left child if it has a left child, as well if it has a right child, a pointer to right child. Usage of binary trees in Java. These binary trees are used to store information, and it makes a moderate access and or a search to information that have stored, and we can use this to moderate insertion and deletions, and for sorting algorithms, for router algorithms, we can use these binary trees. Not only that, it's a form of multi-stage to make more decisions, as the information that have stored are interconnected, so we can make more decisions by using these binary trees. So there are some of the uses of binary trees in Java. As this is a short video, I'm going to describe about traversal of binary tree. So there are three types of traversals. First one is pre-order, second one is in order, and the third one is post order. So in pre-order, it first consider the node, then the left child, after the right child. In order, it first consider the left side, then the node, after that right child. In post order, it first consider the left child, then the right child, then the node. So now we are going to describe about all these traversal methods, post order, in order and pre-order with example. Okay, now I'm moving to the traversal methods. So first one is pre-order. In pre-order, as I mentioned before, first I have to focus on the node, then the left child of the node, after that the right child of the node. So this is the example that I'm using. In this example, I implies that method by using these three letters. N implies node, L implies the left child, and R implies the right child. So first I have to focus on this, the node. So when we are focusing on the node, we just write the node, the value of the node as the output. In every time when it comes to the node, it gives as the output. So now it's moved to the node of root node. So the value is 10. So our first output is 10. Then I have to focus the left side of this knot. So now I move here. It's 7. So it prints 7. And again I have to focus to the left side. The knot value is 6. So I just print 6. After that, the left side, the value is 1. Then the knot, and then the left side. As there's no any children for this knot, that means the children nodes are null here. The value is null. So nothing to print. So it again moves to this. So I have to I refer to the left side of this. So its right side is a null. Then again it's moved to here. So it has a right side. So after that, the left side of 8 is 9. So 9 is printing here. There's no any children, so value is null. I have to again move back. All these two are executed. R is remain. That means looking for the value of right side is remain. But there's no any right side, so it's again moved here. And all these three steps are executed, so it's again moved here. When it comes to here, only these two are executed. Looking for the value of right side is still remaining, so it's again moved here. The right side is 11, value of the right side is 11, so 11 is print here. Then the left side, the value is 20, so 20 is printing here, and this is the output. Or if it's move here, all these three are executed, so nothing is remaining. So this is the output of this tree in a pre-order method. Now we are moving to the second traversal method. It's in order. So in order, I'm going to describe that in order by using this example, the same example that I've used in pre-order method. So in here, first I have to focus on the left side, after that the knot, then the right side. So let's start it from the beginning. So when we consider this knot, first I have to focus on the left side of that knot. The left side of that knot is 7. So I just have to focus the left side of this knot. So left side of this knot is 6. And I have to focus on the left side of this knot. The left side of this knot is 1. But the value of that knot is 1. Then I have to consider the left side of this. But there's no any left side. So there's no left side, so it's focused to the next step. It's the knot, so it prints 1, and I have to look. I'm looking for the right side. As there's no any children, it's null value. It just move back to this. Then it execute. Before I have executed this part. Now it's executing this part. So it prints 6 and looking for the right side. There's no any right side, so it's also moved back like this, and this it's executed left before, so now it executing this part. So 7 is printing here, and it's moved to the right side of that knot. It has a right side, so it's moved here. So still this part is not executed, so it has to look for the right child, so it's moved here, and the right child of this is here. It's this node, and the value of that node is 9, and this node doesn't have children, left child, so it prints 9 here, and this part is no, so this part is executed, but as there's no any children here, value is null, so it again moves back, and first this part is executed, so now 8 is printing and looks for the right side. There's no right side, so it's moved back. In this case, all these parts are executed, so it's again moved here. This one is executed, and this is the one now we are now going to execute. So 10 is printing here, and it moves here. In this case, all these steps are executed. So this is the output of this binary tree in order method. Now I am discussing the last traversal method. It's known as post order. So in post order, first I have to consider the left side, then the right side, after that the node. So let's begin from here. So it's the root node, and the left side of the root node is this, and so this one executed, so I have to look for the left child. So left child is this, and the left side of this one is this, but this one doesn't have children, so this one is no, this one is no, so this one is executing. So one is printing here. After that I have to move back. This one executed, so I have to look for the right child. There's no any right child, so this one is executing. So 6 is printing here. After that it moves back. This one executed, so now I have to look for this. The right child, it has a right child, so it moves here. Again, this one I have to consider this one, the left side of this. So left side is here. In this case, there's no any children, so this one no, this one is print. So 9 is printing. Again, it's moved back. So it this one executed. There's no any right side, so this one is executing. So it gives 8 as the output. Again, it's moved back, and left are executed. So this one is executing. 7 is printing here. Again, move back to the root node. The left side of the tree is considered, and now I have to consider the right side. It has a right child, so it moves here, and when it comes to the root node, it considered the left child and the right child, so this only this part is remained to execute, so it refers to the node, therefore it gives 10 as the output. I hope you got an introductory clarification about these binary trees as well the traversal method. So thank you for watching my video.